Greetings, and today's microcontrol we'll be studying about the timer programming. So under PIC 18 we'll have about 2 to 5 timers. So they are referred as timer 0, 1, 2, 3 and 4. So these timers, they can be used as a timers when they create a delay, or else they can be used as a counter when they need to count the external events that's happening at the outside the microcontroller. If it is used as a timer, this will be making use of the internal clock frequency, that is a crystal frequency. So that frequency, it gets divided by 4, that is mentioned as FOSC divided by 4. So that is a frequency used by the PIC when it is used as a timer, or else if it is used as a counter, the pulses may be produced at the pins, external pins. So depending on the kind of the timer, the clock pulses may vary at a different pins. So these are basic registers that is used by the PIC for the timer. For example, each timer will have some associated registers, and they are called as a low byte register, TMRL and TMRH. That X represents a kind of timer. If it is a 0th timer, timer 0, you can put 0x instead of X, you can put as 0. If it is a timer 1, you can put as 1, or else as 2, it goes on. So these register will hold the value, so that the timer can act as a up counter or up timer for a particular value. So based on the specifications, these timers has to be loaded to create a delay. Now these registers are called as a timer register. One is a low byte register, another one is a high byte register, and each timer will have some kind of register additionally, which is called as a timer control register. This control register will hold the mode settings and all kind of information configurations. For example, when we see timer 0, timer 0 can be used as an 8-bit timer or a 16-bit timer. So, and we know that we have L register and a H register. Each registers are 8-bit register. When this is used as an 8-bit register, TMR0L is used. When this is used as a 16-bit register, TMR0L and TMR0H has to be used to make it to work as a 16-bit register. And we have a timer control register, which is called as a timer 0 con register. This register can control the timer, whether it has to be work as a timer or a counter, or what is the clock pulse that's need to be done, whether it's a low to high edge or high to low, the timer has to count, whether you need the crystal frequency as such, or any kind of pre-scaling has to be done. All these can be configured using the timer 0 control. So this is the timer 0 control register that is shown here. So D7 bit is a timer 0 on bit, and D6 is timer 0 bit, whether it has to be used as a 8-bit timer or a 16-bit timer. So if that is set to 1, it is an 8-bit timer. If it is set to 0, it will be acting as a 16-bit timer. And the next one is the timer 0 clock source. If it is 1, it is external clock, that is a processor. The timer will be used as a counter. So here in case of timer 0, the port A's 4th pin will be used as a clock source if this bit is set to 1. If it is bit set to 0, it is used as a timer where the frequency, the crystal frequency, gets divided by 4. And you have a timer 0 source edge select bit. If it is set to 1, every high to low transition will make a 1 count up. Similarly, if it is this bit is set to 0, low to high transition will make a counter to count up. And you have another bit which is called as a prescaler. If that is set to 1, no prescaler, it means it has to bypass a prescaler. If it is set to 0, there is a prescaling. And the remaining 3 bits, timer 0 PS0, timer 0 PS1, timer 0 PS2 will be acting as a prescaler selector. If it is all zeros, it will be crystal frequency divided by 4 in all the case of timer, further divided by 2. And similarly, if it is all ones, crystal frequency divided by 4 and further divided by 256. And we have another register which is called as a timer 0 interrupt flag, which is available in a INTCON register. So suppose if this timer is used as a 16-bit timer, and once it starts from 0, if assume that the timer starts from all zeros, so once this timer 0 is set on, it will start counting up. When it reaches all F, that is 16-bit F, you have 4 hexadecimal values. When it rolls over, again FF gets incremented, it gets rolled over to 0000. So at this time the timer 0 interrupt flag will be set to 1. So timer 0 interrupt flag is available in the INTCON register. So while one has to write the program, he has to configure the timer 0 control register, and again once the timer is started, one has to check the interrupt flag whether it is overflow. Once the timer flag is overflowed or is set, the programmer can write what has to be done next. So this is mainly based on the program. One has to write the program. This is what is a timer 0 interrupt flag. So this is in the INTCON register. So you can see it is available at the second page, that is D2, 0, 1 and 2. From the left you have the interrupt flag, and the below diagram it shows how it works. You have a crystal frequency gets divided by 4, and once the timer is on, the values that is loaded into the low register and high register will start counting up. One fine time it will reaches all F and it gets roll over to 0. So once it roll over to 0, the timer flag would be set to 1. You can see an example here. So here this is a configuration that is given for the question. So it is given to find the configuration value in the timer 0 control register for timer 0 in 16-bit mode and with no prescaler. So based on the timer 0 control register, these values are found. And similarly, the second below question can be found is a question to find the value of the timer, that is the time of the timer. So suppose the crystal frequency is 10. So what does it mean? 10 megahertz divided by 4, you will get around 2.5 megahertz. Once finding the time, you will get 0.4 microsecond. Suppose the crystal frequency is 4, you will get 4 by 4, you will get 1 megahertz. And so finding out the time is 10 power minus 6, it's 1 microsecond. And this is another question. If you have a prescaler of 1:64, what will happen? You have a crystal oscillator frequency gets divided by 4, further divided by 64. That is a timer value, that is a in frequency, and once you take the reciprocation, you will get a value. For example, if your crystal is 10 divided by 4, you will get around 2.5 megahertz. Further divided by 64, you will get around 39062.5 hertz. And again 1:64 one can do, and so you will get around 25.6 microsecond. Similarly, if your crystal is 60 megahertz, you can again do the same program, but with 60 megahertz instead of a 10 megahertz. You will get around 16 microseconds. Thank you. We'll see the remaining in the next class.